right, so hopefully that was shorter than expected. And now I'm extremely happy to welcome Martin to start the conference with his keynote talk. And I'm very, very grateful that he accepted our invitation, not only because I've been using R for a long time, and I'm very, very grateful for everyone in the R core and who contributed, but also I'm an avid Emacs ESS user. So thanks a lot. Please welcome Martin.
Thank you. Okay, I see my mic is online. That's good. Now the computer has to get online too. And of course we have to do that all. Yeah, usually it accepts my finger, but not when I'm nervous. Okay. Perfect. There's one thing, remark, we have an LED screen here which is perfect for videos but not perfect for R code. So the slides I will put them online and tweet about where they are. They're not already there, but anyway. So the people in the front row in general, in this room, if you are in the first few rows, you can read R code, otherwise probably not. First introduction, just history, because I'm an old guy. And interestingly, there's, thanks to maybe some of you who made sure that it worked, there's a nice Wikipedia article about R, which also mentions the history of R. You cannot read it on this screen, unfortunately, but anyway, there's the first section is called History. And yeah, I can make that large, maybe. We can read something, at least the first part. So R is an implementation of the S programming language. Probably more than 3/4 of you don't know that anymore. Roger Bivand, an R Foundation member, will explain that. R was created by Ross and Robert, and there's a little bit history here, and I was involved in that history. And so for once I want to mention that too. R started very early. There's an article very hidden on CRAN, which, as you can see, it looks like the 90s. And it is actually from the early 90s. It's, if you look at the bigger context, it's a draft for a paper for the Interface 98. So this is really history. And it's a good, because the nice thing is it's written by Robert and Ross, or actually by Ross. He writes the initial work on R by Robert Gentleman, and I produced what looked like a potentially useful piece of software. We were heartened enough by our progress to place some binary copies of R at StatLib. That was the place where you used FTP at the time. HTTP didn't exist, or at least only at CERN where they researched, and made a small announcement on the S-News mailing list in August 93. And then they mentioned me a few times, because as it happened, I was really partly instrumental. A number of people picked up our binaries and offered feedback, and we agreed to make the source code available by FTP, the only thing at the time, under the terms of the Free Software Foundation's GNU General License, the so-called GPL, for those who only know the nose. This and the thing is that some people picked that up, and the most persistent was I, who encouraged us to release our source code as free software. And actually, what they don't say, but I think that was very important at the time. Many people, particularly in Europe, were looking forward to have free software, in the sense, yes, we use it. It's not something from North America that is a big company that sells things and takes our research away, or whatever. So far about that. So that was the wrong thing. Yeah, that's the problem if you use what I do to switch around. Because I seem to have almost lost my presentation, which of course I have not. That should not happen to anybody. what it is. Okay, I've done this many, many times when exercising. So I have to go back to the browser and open. So sorry. Okay. No, that was not the version. I had it on purpose, and that's neither that. Okay, this should not happen in reality. Sorry. I just open it again in one version of my browser. I can do that. I did it so many times. Sorry. Good. R became free software in 1995. Under the GPL, as I said, that was very important. It's free and open source, and that's not free as in free beer. And read it up if you don't understand that. This is important to the heart of most people in the R Foundation and the R core team, which was formed in 1997. And here is a list of people. You cannot. That's if you go to R's webpage and click on contributors down here, you get to this page, and then there's the list of 20 names of the R core team, and here is an also list that you cannot read on this screen, unfortunately. Maybe you can kind of decipher some names. It's nice that we are 20 at the moment because we can nicely arrange it in a 4x5 matrix. There are 2 Martin M, and so there are 2 Martin M's now. Martin Morgan, I was just confused with yesterday. Good. R is actually R base, what R core does, and all the packages that you do and many others. And you've seen some graphics like that before, but just to look back. I mean, R wouldn't be what it is without packages and without Kron and Kurt Hornig in Vienna and the other Kron team, mostly always very much located in Europe. R wouldn't be what it is without Kron. If the growth is exponential or not, there have been user talks who fitted a 3-parameter model, growth model to this curve. Concluded it was not quite exponential. This is a log scale here. It looks a bit, so we are 12,500 at the moment. And the question, so if this was a linear line, then we would have exponential growth. Okay, you all know the problems with that, and I will not say much more. So back to things that are much more to my heart. The art of R programming. The whole talk will be about R programming. There will be a last time about future and current developments within R that are important. But this is important too. R is an art, and arts you learn by having a master that you learn from. The masters in computer science is, well, maybe R course members, Harley Wickham, many other good people in the R community write very good R code. And I think reading, and I learned S at the time, and R, and even C, I mostly learned by reading source code from good people, and then looking up documentation and reading that too. Use the source look is a not Obi-Wan Kenobi from Star Wars who said use the force Luke to Luke Skywalker, of course, but use the source means read the source code. So this is kind of a standing thing in computer science. Read our source code to learn from the master. This is not something people tell you often, but actually Colin Gillespie in his talk about essential art just said something similar. So how can you do that? Instead of just Googling and installing the package, which most of people do nowadays, if you want to become a bit more advanced, learn to use the source. It's a small effort, yes. There's a relatively recent kind of GitHub blog from Jenny Bryan, also a member of the R Foundation, about accessing the R source of R itself or of R packages. It builds on an article in the R Journal, which I also recommend you to read, even though it's not as nice as a shiny demo, but you learn a lot from reading, or at least browsing and reading some articles of the R Journal. Why don't you download the R source and package sources instead of just installing them? If you do that and take some time occasionally, not weeks in a row, it will be rewarding, I can promise that to you. Some saying, as I come from academia, R started as a software to do really serious, nice, reproducible research, and it's still used for that very much. And so reliability and scientific reliability in this case is important to me, and that's why I like to emphasize to people, to clients, to students, that they should use, in some sense, validated packages. Of course, it's only in some sense. But if you install a package from GitHub of somebody who you don't know and don't be sure about his or her reputation, you can install a virus. I don't say there are on GitHub, but in principle, if you just download R software, there can be anything. So you really should use your sources and know what you're doing a little bit. And Cron and Bioconductor, for instance, have very rigorous testing before they accept a package. Anyway, download the R source, and Jenny Bryan's write-up tells you how, but you can also just go to the Crown landing page of a package and look for source and downloading it. And if you do that, you get the file that is called package name _ version of that package .tar.gc. And if you're not a Unix macOS user with Windows, you probably haven't heard of them, but install a program if needed, I don't know, to automatically open this in an archive format and unzip it and look at how this package is written. And for instance, look at some of the R code. I'm stopping here. There's much more I could say. I had talks that take an hour just on that. So second part, programming with style. It's an art, and art and style, of course, are related. Style is also more about fashion than art, but anyway, a little bit. There is this nice thing, I don't know how many have seen this before. I liked it. It's actually it appeared on May 7th, so only a couple of days ago. I think I saw it a little bit earlier on one of the channels I occasionally have time to watch. The so-called Stack Overflow keyboard with 3 keys, Control, C, and V, and probably everyone knows that this is for copy and paste. So that's about programming with style. What is this about? This is about people use Stack Overflow to learn about solutions to programming problems, and it's a very good source, and it's very nice in many ways, but you can overuse it. And here the style that I'm emphasizing here is basically about this: dry, not wet. Wikipedia explains what dry is, DRY. It's really DRY. It stands for don't repeat yourself. And it has a whole article, and I'm citing a little bit from there. There are books written in computer science about this principle. It's more general. So the principle is every piece of knowledge must have a single, unambiguous, authoritative representation within a system. Sounds a little bit abstract. Basically means everything should only be there once in your code and in your data. This is a big principle, and goes, of course, also to not have copies of your address list in 3 different places manipulated by 3 different people. So that's something that's not very much related to our programming, but still. Don't repeat yourself. If you have a repetitive task, write an R function to do it and call it twice, even if you have a function that you originally only want to call twice, if you have it, you easily call it several times with variations in the arguments, and you quickly get much more powerful, much more insight. So this is really part of an important book that is about 10 years old now, or even less, or even more. The Programmatic Programmer. There's more about this, about the drive principle. The idea is that if you change something somewhere, you don't have to change it simultaneously anywhere else, because the place where you change it in principle is used from everywhere, and so that's of course a very high principle that most of us cannot follow, and that R core cannot or has not followed with the sources of R itself. So modification of a single part often redefines a part of the API that you have to do about it. But it's a very good thing. We use computers not to do repetitive tasks, because the computer is very fast and efficient and reliable in repeating this thing. And that should be a guiding principle in R programming as well, and in writing R functions. Okay. What is wet? Well, dry is dry. That's not what the weather is. Today is wet. Wet is not good, particularly if it's here. What does it stand for? Write everything twice or more. Or we enjoy typing, or waste everyone's time. Anyway, so that's computer science joke. But yeah, remember, DRY, don't repeat yourself. Do not use copy-paste programming. Do not use the Stack Overflow keyboard. Only use other parts of the keyboard. And sometimes I see extremely much wet solutions in R code. Start not to do that. That is the real danger. If you find a bug in your code and you fix it in this one place, you have not fixed it in the 3 other places you used copy-paste from the first place. So it's a nightmare to maintain code if you don't adhere to that principle. A few more remarks about style, then I'll finish that part. Please use the left row, the nice double character sign instead of the equal sign for assignment. One time, R is a functional language. Assignments should stand out, so that's why this is really so much nicer than that, because in R the equal sign is used for many other things, for function calls when you name by arguments, and for the default values when you specify the formal arguments of a function. A functional language, for those who know a little bit more about computer programming, that R came from, actually assignments should stand out. They don't quite fit the functional paradigm. And both RStudio and ESS have alternate minus to produce 4 characters. Well, this was messed up again. I tried to make this nice. Anyway, it's space less minus space. 4 characters are produced by pressing 1.5 character. Alt minus on both good GUIs. And I see many RStudio users who actually even use the RO and type 4 characters. Change your habits, and then you can teach others to change their habit and really use alt minus to add the assignment. So please is not only by me, also Hadley Wickham in his very nice book on advanced R in a small section on style advocates that. Do comment your R code. You will be glad already in 1 month if you're older like me, or maybe in 3 months if you're young. But you will get back to most of your code at some time, and if you have comments, that helps. Of course, you should think how to comment smartly, but do it. Use spaces in your R code. Probably most of you have seen that. And there's a small remark that is kind of important to my heart. Be better than pretty printers. Pretty printer is an old word when output was still mostly on paper. There are now several packages that do that. RStudio kind of does it for you if you tell it to. But you can be better. We humans, we don't have to do like algorithms. Algorithms are good, but if art programming, a program is an art, artists are better, still much better than machines and algorithms in producing art. Maybe not in the distant future. So I show you one example, and I'm sorry that maybe only few can read it. I can make it a little bit larger and cut off. So this is really from the R source code. It's a S3 method for drop levels, a data frame method. So it's not something you use very often. It's kind of, I had to use a small function where I did not use a computer-aided indentation. So here, and I now make it a little bit larger so I can a little bit better show. This part here is not, we'll get away with the color. This part here is not indented by an algorithm, but by a human who thought, and I think in this case it was me who changed even the indentation. We have an if-else statement, and in both cases do basically the same, and so this is in some sense that DRY cannot be used in extremis all the time, because missing exclude pass to that lapply doesn't work. But anyway, this shows in both cases I do basically the same thing with this one difference. And you see this very, very quickly because they are aligned exactly. If I use standard indentation, this would go 2 letters further to the left. In this case, only very little, but in other cases, there's more. Anyway, so you can use spaces and you can do better than an algorithm. So try to be better than in indentation. But if you are too lazy, then at least use this automatic indentations. Spaces is important for style, for reading your code. Third section, R programming. Okay, I should get back to what we had. If we have no R code, we can read it like that as well. John Chambers, in his latest book and also in the talk at the second last use R, I think, said 2 important things about when you start to think about what R as a language does. Everything in R that exists is an object, and everything that happens is a function call, anyway. In R, everything that exists is an object, everything that happens is a function call, and so nothing happens that is not a function call. If you're using RStudio or an IDE, of course you use other things than R on top of R. Then if you click somewhere in your IDE, that's not an R function call necessarily. Often it leads to an R function call. Okay, you call functions all the time when you use R, and that a consequence for good R users like you, and like you should become, as you should become, do write your functions all the time. Write one-line functions, write functions that just do one little thing that you call 3 times in your code. Don't repeat yourself. Instead of repeating yourself in your code, write the small functions and call that. If it's only 3 times in your bigger function, that already makes your code much more readable and maintainable too. Because if you want to change the behavior, then if you change it in that small function, it's used consistently everywhere in the other places in your function. And the last thing, do learn about lapply, which you probably all know, but also learn about do.call. Do.call is really a very powerful function. You should know when that it is usable and can be used. Often it's the function to solve some not trivial, nice programming problems. Do.call. Okay, write more functions. Write functions within your small functions, use them. That helps you in the long term a lot. And then test. And of course, I'm not giving talks on test. I think there are several in the conferences. Something very small. Many people have used functions. If there is something not good in my input, then produce an error message. So if there is a problem, stop with a reasonable message. And I wrote the function stop if not, and if you don't like it, you can blame it. Yes, it was Martin. Stop if not, just in order to make this nicer, to do several things. Stop if not something that has to be true. So not here is the problem that you emphasize on. Give an error. Here is what you really want, the positive thing. What must be true, what must be true, and must be all true. And so anyway, you can use that. Or alternatively, since our version 3.5, I've improved that to a version that is nicer if you debug and develop the tests. Namely, here you now have lines that you can send to your R process from RStudio or ESS or whatever IDE you use. So there are no commas here anymore. And you can use this new syntax expression equivalent and use a set of expressions. with no commas. Of course, this is still useful sometimes, but the other one is used if you use this. And you can consider this as something like unit tests if a unit can be larger than a single thing. And it's very cheap. It's where you can read this code. The stop if not function is partly relatively simple. You don't need extra packages. You don't have to rely on any other packages. Good. And I know there are a dozen packages for testing and even for assertion, and they are nice in themselves, but something new to learn. This is just one function to learn. Put your functions in a package, of course, test, and then you can test them even more thoroughly. You can use the tools that nowadays are provided, unit test, test coverage. Write nice help pages including examples. That's something I don't see so often anymore. I hope it's not related to people using Roxygen often, because in my view that helps to not write examples because it's get a bit awkward. Write vignettes and build packages that are sustainable. That's another topic. Okay, now the last part of my talk is about new things in R350. Only a little bit of all the new things in R350. There is much, actually. Much of it is really detail and not interesting to you. And mostly about this thing called altrep. Because I'm the only person here close to that, to the only core person here, and the people who really worked on altrep are not here. I feel entitled to tell you a little bit about this. But many R users don't read the news about R, and I again want to emphasize, well, we do a lot of work, and so there's an item on the web page. If you click on the left, there is news, and if you go to that news page, and let me try that again and hope that I don't lose it this time. You get to this page, and the very first thing is changes in R, and then it's the R announce mailing list, which announces R conferences and new members of the foundation and the core team, and new R packages, but this people now prefer Twitter and other things rather. But still, that's used. Anyway, if you click here, you get to that other file, which is the news that, on an HTML page is formatted like that. And let's quickly browse on that. And so significant user visible changes. So the altrep is not the typical user visible change. So that's why it's not here. Just let me mention that. All packages are by default byte compiled on installation. Well, you can argue that users don't see this. But you'll probably notice this. Byte compilation has been increased a lot. Has been introduced a longish time ago, but now it's everywhere, and it has been improved much, and it's paying off almost always. Originally, there were cases where it harmed, rare cases still, and I think they have all been eliminated. So that's why everything is byte compiled, and some of you may have noticed if you look at functions, even the functions that you just define a few lines before, after the first use, they are also byte compiled. And now the list of new features, and there are many, and we cannot. But I occasionally still recommend to browse slowly through and look at one or two cases. There are also new functions introduced, important features. If I search forward for alt, then you see also that stop if not now has this new feature to use these expressions without commas, which is nice for unit testing or test scripts in general. Then there's arithmetic sequences do now use an internal representation, which is much more memory efficient than before, using the altrep framework. And if you search again, then there's a new serialization format. Now, I assume that 95% of you don't know what serialization is. This is about saving R objects in a file and then reading that and get exactly the same R object back. So you have to translate an R object into a series of bytes, and that's why it's called serialization. There's a new format. The formats in R are now numbered, so if you read stuff and if the format is wrong, you get error messages or warnings. And there's more about it I don't want. And then the big thing here, the bottom of the new things is that now we have a framework that allows packages to provide alternative representation of basic R projects. The only documentation is in this document, which is actually part of the R source code. If you see here, svnrproject.org is the server of the R sources. Okay, so that's the point, which I have a quick summary on the main here with the same links. Alternative object representations. This is not something you easily see. What's the history? Not quite 2 years ago at the USR meeting in Stanford, actually after the USR meeting, there was a one and a half day developers meeting. Gabe Becker talked about his ideas on the potential of that. I mean, he gave a presentation. And our core member Luke Tierney, who also introduced the byte compiler and everything, agreed to form a working group about that because some of these ideas had been around for several years. Also because the documentation again is here. I've already mentioned that. I want to also quickly show you how it looks. And now we should see that, but not here. Well, maybe I leave it. And there's another talk that I give you the reference here where it explains a little bit. But I want to show you more. I don't talk much at the moment, just for time reasons, about why this is so useful or why this has a lot of potential for the future of R, but just what is currently present. So this is actually adapted from that document I just mentioned. And that's you already read. So integer vectors can be compactly represented, or actually are, if you use the colon operator or the function sekalong or seclen to produce that integer sequences. In R 4.4 and older, if you did, and now again, of course, with the bad screen, maybe we can make that a bit. Don't. So if you type x becomes 1 double column 1e10, so that's 10 to the 10, that's 10 billion in English. Then you get the error message, cannot allocate a vector of size 74 gigabytes. Of course, there are RAMs that are 120 or 200 gigabytes, but most usage of R will not. And even if you have 100 gigabytes of RAM, which I have on some servers, or we have, at ETH, this will take minutes, actually, or even more. I haven't tried it there. Just creating that takes a long time, even if you don't. And by the way, if you try this on some platforms, I think on the Mac OS, your R may crash, actually, because it realizes too late that it cannot do it. So it doesn't. Sometimes it doesn't give you that error message. At least in older versions of R. Mac was something special here. Anyway, in R350 and later, and also the altrep branch, this now is immediate. I mean, this is 0 millisecond operation. So if you measure it with system times, it says 0 milliseconds. And that's nice. Implication is for loops actually can be faster. This example here is extreme. Just try. So system time of 4i in 1 to 10 to the 9th, only instead of 10 here for some, I don't know. And break means actually in a traditional R it creates this vector, right? And then it starts a loop about it and immediately leaves the loop. Break means leave a loop, for those who don't know that. But it has to create this object. So in R44, on my laptop, it needs about 1.5 seconds. Whereas in R35, in the current version of R that I of course used to knit these slides, then it takes 13 milliseconds and sometimes even less. Okay, there's only one way to really see that thing here, because this thing is partly experimental, and we want all our packages on Crown and Bioconductor and GitHub even and everywhere to still work the same, even if they use C code and RCPP. And for that, there is not, most cases, such vectors behave as if they were previously, as if they were using all the memory. So if you use internal inspect to look at that vector, it now says something like that. Yes, this is one column and then 10 to the 9th, so a 1 with 9 zeros, and this is a compact representation internally, and that's why it's so fast to construct. And it has never to be constructed here, right? And also not if you do something more reasonable. It can access this one by one, but it doesn't have to construct it. But then it doesn't gain so much time. But it still saves very much memory, maybe. Sum of x also has been written to be smart for such integer vector. It uses the formula that allegedly Gauss did as first grade in a first grade primary school, when the teacher asked him to count the numbers from 1 to add the numbers from 1 to 100, and thought that Gauss would need an hour for this thing. And then, of course, he derived something like this formula in his head, or by thinking, by using the pairs. And that same smarter version, because of R, this works for any integer sequences, not only those that start with 1. So this is immediate, uses 0 milliseconds, and of course does not loop around this. And I checked that is actually correct, because this is only 1-digit precision, but this is now really full. And mean has been adapted as well, but it is not fast. In this, for integer sequence, mean can, of course, is just, in any case, it's just sum divided by the size. And anyway, let's continue. You can also do 10 to the 15, of course. That's not imaginable in any version of R. I don't think there's any computer with so much RAM. And if you ask for object size, and I wanted to show this so that this is somewhat experimental, because everything should behave as previously. Object size reports the size that this would have if it was expanded. So it reports 8,000 terabytes. Yes, which is fortunately not quite true. There's more about these vectors, not only these, but others. The altrep objects can remember that they are sorted. And so if I ask for unsortedness, because that's typically more useful in if statements, we had defined a function like that, it gives false immediately. So this is also in 0 milliseconds according to system time. If you sort it, because R already knows it, it's instantaneous as well. And if you inspect XS, it's a copy of X, of course, because R already knows that X is scored. So it's the same thing. And the same about NAs, because some of you may have been aware that lots of stuff in R, sometimes things are a bit slower in matrix operations, because if you don't know that there are no NAs, you have to check it, and otherwise these linear operations on matrices can be very, very much optimized. And so if you know that there is no NA in your matrix in advance, then you can do shortcuts and be fast. And so any NA gives false here, it's cut off, because I show you higher resolution. Immediately, again, milliseconds to know that. There's another important nice thing. That's the last example I'm showing, and then I'll finish. Conversion of numbers to strings is expensive, even though strings are relatively, in itself, a relatively efficient way to store such objects. And design matrix, as the statisticians call them, X matrix in linear models, in regression models, they are design matrices. They have row names, because that's, in typical application, that's nice and good, and you want to see which observations are extremes in your residual plots and everywhere. They call as character of this vector typically, and in altrep, that happens. So if you do such a compacted integer thing and convert it to character, it's actually not converted yet. This is a deferred string coercion. That's the technical term. Coercion to string means make this to a string, and deferred means I don't make it now, but I will do it when needed. So if you inspect this character vector now, it says I'm a deferred string conversion, and actually I will convert when necessary from this compact integer that we've already seen. Okay, and what's the consequence? The consequence is actually, well, let me first show you the consequence. So we are fast, for instance, in extraction. Here we extract 3 elements, starting from 10 million up 3 elements, and that's very fast. The full vector is never constructed, and it goes along the integer. Basically, you can imagine. So it uses 0 milliseconds again in elapsed time. And even though we accessed the vector to extract something, it's still unchanged. So in memory, there has nothing bad happened. I can also use head, which shows the beginning, which also extracts the first 6 elements and doesn't change the internal representation, as you can see here. Yeah, I'm really sorry for the bad resolution. On the top, you say that you still have this deferred object. Another so what happens if this object is really needed? So that's why I now use it of size 1 million only instead of 100 million. If you now really change the first element to the letter A, then it can no longer be the conversion of an integer vector, because that doesn't work, an integer sequence. So this operation actually in itself is long, because it takes almost half a second. 350 milliseconds about. And if you now inspect the vector, then it prints very different. It says, yeah, I'm of a length 1 million, and now actually I have all these character objects. They are cached in some way, because strings are cached in R, which is another thing that makes them relatively fast. But still, it's expanding, it uses memory. Why is this good? Well, LM, the standard version to do regression, least squares, becomes much faster for large n, which is amazing. This looks teeny finding actually that this was something. So if you define 10 million random x and y and do a regression of y against x in R350 and up, this first time 2 seconds, second time, well, 2 point something, and a little bit less than 2. That's the byte compiler. Also, even second evaluations often take a little bit faster, or faster than the first, even if it's not about the function that you defined. And the times in R44 and earlier were 11 seconds and 9 seconds based. So this is a factor of 5 faster of LM, which is a bit surprising, right? And it's because we are not creating row labels for the design matrix, but the row labels are actually a deferred character vector. And yes, the RCPP fans around us and others know that you can do regression faster than LM, because LM has to deal with the formula, create the matrix, create terms, do all that. So if you use base rs.lm.fit, the function that I also added to R a few years ago, only relatively few years ago, and even if you do cbind of y, 1, x to have really the same regression, then this is 3 times faster than the new solution. So this is, but LM of course has all the other informations about the residuals, about things. So that finishes my presentation, which is good. I'm in time, so I'm RCore makes base R. It's base R is not the same as RStudio, as some students nowadays think. The art of R programming. It's not all about just following standards. We are not algorithms. We are not just better algorithms. I don't think we are. So we should do what we are good. We are better in some things, particularly in art. And writing nice, readable, human, understandable code is partly in art, not always. Use the source loop. R programming with style, aim for dry, not wet. R programming, which means actually something like the fourth part, write more functions, write one-liners within your function, makes everything nicely readable, but much better maintainable, less error-prone, and so on. And the last part was about this alt-rep, alternative representations. That's all, folks. And if there are questions or remarks, that's a good time now. There will be someone with a microphone, and I'll repeat the question if otherwise. Thank you.
Thank you very much. we have time for a question or two,
Okay.
and I will be running it around. So just raise your hand, and I will go there with this microphone.
Yeah. Do you want to? Yeah.
Come on.
Yeah. He started late already. But I wasn't overtopped anyway. So, somebody will start
Thank you,
again for you.
Martin. Thank you for an enjoyable talk. You said hi.
Okay,
it's
thank you.
fine.
Yeah, that's the problem.
Thank you very much. I enjoyed it. You said that due to time constraint, you are not going to talk about the consequences of the alt-rep for the future of R and what that entails, but maybe you can take a moment to give a hint as to what you meant.
Yes. So, of course, I don't really know the future, not only in R, but the potential is large, and it's. So you can read about that extended documentation, the document I had a link to. But one thing is, one can really, for instance, think of having a different numbers. 64-bit integers is a very big topic for some of you, and I don't know if this will become fast or at all. I cannot promise anything. What I actually did not show of the three names that go with this is really Luke Tierney, Gabe Becker I mentioned, and Thomas Calibera. They are, I think, and Michael Lawrence. So Gabe not in our core, and the three R core members, they really did all the work. I did nothing of that. But the idea is you can now introduce new objects in many different senses. So in their extended documentation, for instance, they showed how you can have vectors that are actually files. So they are, in some other ways, they are not limited in size as previously. So there's even an experimental R package that you can download, actually from GitHub, from Luke Tierney's repo, that uses the alt-rep-C API to have file mapped. File mapping is a standard technique, and there are R packages that do file mapping already, but that's now, you can do this with alt-rep very naturally. So that's another of such applications.
Yes. Well, first of all, thank you for a wonderful talk. I'm here.
Yeah, thank you. Do that always. From here, you see the okay.
And also for all your work for the R core.
Thank you.
I was just wondering. Lately has been some discussions online and on Twitter on using ligature for representing code. So, for example, the assignment arrow would be shown as a single character. And personally, I'm not a big fan of it, but since you're talking about coding style, I'm wondering, what do you think of it?
Oh, actually, I haven't seen this discussion, but I know Julia a little bit. It's a beautiful language. It's nicer than R as a language, but it has other big flaws in some sense. And Julia uses Unicode character everywhere, so you can write the letter pi, the Greek letter pi, for really the number pi, and many other things. I think in principle this is already possible in R. You can define this already now, but it's clumsy, and it's not something we have talked about within the bigger R core, but we are 20 people, and sometimes people talk in smaller groups. So I cannot say, unless it hasn't been to anybody's urgent needs, but it's in some ways it's kind of nice, I agree.
Let's thank Martin again